In the research report Cannabinoids Function in Defense Against Chewing Herbivores in Cannabis Sativa, F2 populations of Carmagnola and USO31 crosses with higher CBDA content at Cornell Agritech in Geneva, New York in September 2020 sustained lower amounts of damage in the field, as well as in controlled tests in the diets of Trichoplusia knee, the common cabbage looper caterpillars or knee moth, as adults. Because of their proximity to the reproductive structures and antagonistic effects against various herbivorous animals, cannabinoids are purported to have at least a beneficial defensive effect and possibly other functions. While insects do not possess CB receptors like humans, various disparate insect species have been shown to respond differently to the presence and absence of structural cannabinoids such as THCA and CBDA, while other compounds that bind with CB receptors like the dietary cannabinoid E-beta-caryophyllene has a wide range of interactions with both positive and negative effects across insect kind. Insects have other receptors like GPR55, TPRV, and PPAR-gamma that may interact with cannabinoids. In some cases, the effects of cannabinoids are insecticidal at levels at relatively low dosage, such as with the larvae of flower beetle, sawtooth grain beetle, Indian meal moth, and tobacco hornworm moth, while some insects like Drosophila melanogaster, the common fruit fly, preferred food with certain phytocannabinoids. CBD is a P450 enzyme competitor for other compounds like the blood thinner warfarin in humans and can interfere with when they become processed and how long before they break down, and in the fall armyworm Spodoptera frugiperta, similar interference was detected. In tobacco hornworms, CBD has been found to lethally interrupt exoskeleton formation and alter neural activity, so at least in model moth larvae, there is a precedence for severe antagonistic effects. In this study, CBDA concentrations of 0.1% lowered survival rates precipitously. Of course, many growers know Helicoverpazia and other budworm moths have no problem and almost exclusively feed on flowers rich in cannabinoids and many other volatiles. It is worth noting that many model caterpillars are generalists like the fall armyworm and cabbage looper that displayed negative effects in research, as are the voracious budworms, which could mean that specific adaptations are that much more necessary for cannabinoid resistance for moth larvae. Field trials also recorded insects like Japanese beetle Popilla japonica, western black flea beetle Phyloatrida pusilla, potato leafhopper Empoasca fabi, and tarnished plant bug Lygus lineolaris.